If you have a drink that's too strong, you might add water. Or if you have this solution at the bottom and you say, oh, that's too dark, you might add water to make it lighter. These are examples of dilution. Dilution is adding a solvent to decrease the concentration of the solution. Now, in dilution, the concentration decreases. This can be seen at the bottom because the color lightens up. But the volume increases because we're adding in water. But the main thing in dilution is that the moles of the solute, in this case what causes that color, remains constant. The solvent changes, but the solute, the number of moles of solute, remains constant. This allows us to use an equation of C1V1 equals C2V2, where the 1 refers to before dilution and the 2 after dilution. The C's are the concentration, which are typically in molarity or moles per liter, and then the volume can be in ml or liters. Now, when we do calculations involving C1V1 equals C2V2, we can either have ones where we have to find the initial concentration, C1, or the concentration after dilution, C2, or we want to find the volume needed for dilution, which is V1, or the volume after dilution, which is V2. But in all these calculations, we're going to use the same steps. The first thing we do is identify that it is a dilution problem. This can either be it saying specifically that there's dilution involved, or it could see something like we are adding solvent or you're adding water. Next, you determine what you are given. So you look at the numbers given and you determine whether that's C1, V1, C2, or V2. Next, you rearrange the equation to get what you're looking for, what the goal of the question is. And then you plug in your values. Let's look at an example. So if we want to make a dilute sucrose solution, and we do it by taking 25 mLs of a 0.84 molar sucrose solution, and we dilute it to 1 liter, we want to know what the concentration is of the final dilute solution. So let's look at what we have. We have a volume here, 25 mLs, and a volume here, 1 liter. We also have a concentration here, and our goal is to find out a concentration. So let's determine what's V1, V2. Well, this 25 mLs, that's what we start with, so that's V1. And we end up at 1 liter, so that's V2. Also notice that in dilution, the volume increases. So we're going from 25 mLs to 1 liter. Now, notice in the text it says 25 mLs of a 0.84 molar solution. That means that these two things are tied together. So if this is V1, this is the concentration, or C1. And that means we're trying to find C2. Next, we go ahead and we rearrange this equation to get V2 or C2 by itself. So that'll get us C2 equals C1 times V1 over V2. Next, we can plug everything in. 0.84 molar, 25 mLs, and 1 liter. Well, notice, though, that if I have molar, I'm going to get molarity, which is good, but I have mLs and liters, but those aren't going to cancel out. So I need to go ahead and I need to change one of these so that the units are the same. Now, we can either change the 25 ml to liters or the 1 liter to ml. Either one works. So let's go ahead and just change the 1 liter to milliliters. So 1 liter equals 1,000 mLs. So this is going to be 1,000 mLs. I'm going to plug that in there instead of the 1 liter. And now the milliliters will cancel out. And I'm going to get my answer, which is 0.021. My milliliters canceled out, and I get molarity, which is good because we're asked for a concentration. Notice that all of these have 3 sig figs, so my answer should have 3 significant figures. So it's 0.0210 molar sucrose. Here's another problem. Here we are asked to prepare 250 mLs of a 0.15 molar NaCl solution from a 2 molar stock solution. Now, what does stock mean? Well, stock means a stock solution is one that is very concentrated. And so a lot of times you go to, at your school, a stock room. The stock room has stock solutions, which are concentrated solutions that you can then dilute down. All right, so this is one of our concentrations. We're given another concentration here, 0.15 molar. So the stock solution, that's going to be what we start with. So that's our C1, and the 0.15 molar, that's our C2. Notice our concentration's decreasing. And notice that we want to know 250 mLs of that 0.15 molar. So that means this is our V2. Okay? And so we want to know how much of the stock solution is needed. So that's our V1. Okay? So we're given C1, we're given C2, we're given V2. We want to rearrange this equation to get V1. So V1 is going to be C2 times V2 over C1. So we plug those in, 0.15 molar times 250 mLs. We have 2 molar here. Notice the molarities will cancel out. That's good. And this is going to get us 18.8. And notice everything cancels out except that milliliters. So we have 18.8 milliliters. So that is how we do dilution problems. C1 V1 equals C2 V2. And the main thing is to make sure that we pair up what our concentration and our volume are together to make sure that we don't confuse those.